house and it doesn't rain, do you get angry? Right? We're used to living in a world in which we don't have firm answers, but knowing that it might rain is better than not knowing, because it helps us. And this is where I want to have us focus. This is what genetics is going to do for us. It's going to tell us information, not perfect, but more than we knew. How about disease management, pharmacogenomics? Lynn just described the development of drugs. What they're learning is that we can begin targeting drugs based on your genetic profile. Now, we talked about breast cancer. The presence of the HER2 gene in 25% of the breast cancer accelerates the cancer, makes it more aggressive, so you need additional medication, additional therapy to handle it. That's great news to distinguish how the therapy goes. There's a company in California called Genomic Health. They look at RNA production. RNA is the work that's being done by the gene, and for $3,800 can predict the likelihood of success with different therapies and also whether the breast cancer will recur. Again, it's not perfect, but the alternative is not knowing. There's a gene for what's called cytochrome 450 that works in the liver. What's really interesting about it is, depending what version of the gene you have, you may either metabolize the drug very slowly, normally, or very aggressively. Now, here's why it's important. If you're given a drug and you're a slow metabolizer, you could become toxic because it builds up in the body. That gets you to what's called a side effect. Not fun. So if you understand how we metabolize drugs, suddenly we're focusing more on who we are instead of just random. We know about gene therapy, some examples, and stem cell therapy. Whether you philosophically agree or don't agree with the use of stem cells, that's a separate issue. The fact is that the use of stem cells and the storage of cord blood from newborns is an area that will grow. We will find new uses for therapies. This is part of the future. But I want to stop with this because that's dealing with something that's interesting, solving disease problems, but the world is not made up of disease. My view is most of us are healthy most of the time. So we have to focus differently. And so I'm going to talk about how DNA, to me, is the final frontier. We've gone through the 20th century, a wonderful time of technology. I was in the computer field starting in 1964. I worked in mainframes. I had an event take place in 1978, and I missed the future. I was working for Joe Califano on alcohol program policy. I was the GE at the time. I was given the task of picking the technology, the word processor, for GE. They said, geez, you know about computers, you're the guy. Two guys, but not the two you're going to think of, flew out from the West, came to my house, put a little computer on my countertop in my kitchen and said, this is really cool, you ought to pick this. And it had this little thing moving around. I said, this is a toy. This isn't a serious thing. We're not going to use it. They said, no, you really should do it because when you finish up, it come up with us, it'll be great. No, it's a toy. It was an apple. 1978. What I missed was that I was looking at the future. Because what was the future? The past, my present was mainframe computing, expensive computers, mini computers that only companies could afford. They cost millions of dollars. They don't change very much. They're just magic. You type stuff on a card, it goes in. Totally away from us. What I missed was everybody's going to have a computer. Everyone here has one in their pocket. It's called a cell phone. That is a computer. We now have changed the world by changing the way we think of technology in computing. Instead of big, important, solving very complicated problems, it was, hey, can I send a letter? Can I type a letter? Can I keep records on my checkbook? These aren't very major life-threatening problems, but look how important they are. So it led to what? Led to the internet, led to the cell phone. There would be no cell phone if we didn't have PCs. An important area is, think of how fast the technology spins, right? This is my new cell phone, right? Who would have thought 10 years ago that you can slide a thing open, have a keyboard, type stuff with pictures, video, text, and link to the world? That's nuts. Okay. So,
Tomorrow will change.
what?
Tomorrow will change.
It'll change, but that's what's so good. Because when things begin to change, they begin to improve. The cell phone we had 10 years ago is not today's. Same model I want you to understand about biology and genetics. Where we are today is not where we'll be in 10 years. But it doesn't mean you can't use it. So why do I have this? This is a blueprint. It is a blueprint of a town, of a house in Levittown. And Levittown was one of the first planned communities. $11,000. This is really terrific. You can buy one of 4 houses, and if the economy doesn't turn around, you can go back and buy one for $11,000. What's important is that this is what you started out with in 1956. But here's what those houses look like today. They've been lived in, they've been shaped, they've been painted, they've been added onto. My message here is the blueprint you're born with is you're able to change what you are, even though the blueprint's still the same blueprint. So the human body is this wonderful, complicated system that you could consider a bunch of data. DNA, genes, chromosomes, and the genome. And the purpose of this is it shapes who and what we are. It is the blueprint that we work with. That's not the end of the story. Okay. A few years ago, they discovered that dancers have 2 genes, are different genetically in 2 genes than athletes. Interestingly enough, the genes that they found different affect the brain. And they believe that the genes, what the brain function is how they hear music. Because dancers have to hear music when they dance. Athletes don't have to hear anything. Having been an athlete, let me tell you, if you have a football thrown at you, it doesn't matter what's going on. If you don't catch it, it's in the face and it's over. Roughly 1% of Caucasians are born with the gene or the genetics for absolute pitch. It appears to have a higher frequency in Asians. But here's where it gets cool. If you are not exposed to music in the first 13 years of life, it doesn't matter. You won't have perfect pitch. So now you have the environment must be there for the gene. But here's another cool fact. They looked at professional musicians. Because they figured, hey, you got perfect pitch. What a great career path. 20% of professional musicians have perfect pitch. Well, that's not bad. That's higher than 1%. But that means the other 80% don't. So what's the message? To be good at something doesn't require that you have a gene. But if you have a gene, it may help. Okay? So there's a valuable piece of information on this. Okay. The actin-3 gene, this is a little controversial, but I like the data. They found a genetic difference between power athletes and endurance athletes. It appears that it affects the ratio of fast twitch and slow twitch fibers. Now that's useful to know, and there's some data saying that if you work hard, you convert one to the other. But the fact is that if